So where people are making mistakes is they're just going from one point to the other, whereas the question you ask, what's furthest to the left, what's furthest to the right, that's domain, okay? And then for range, what's the point closest to the floor, what's the point closest to the roof? All right, so they're the questions you need to ask yourself. Now here, we're introducing these arrows, all right? So where are these questions? This is where it says 3C, this is the examples that we actually supposed to go through. So I said we're going to break it down into 3 parts. We've had a look at worksheet 1. Next, we're going to do these 3 examples and do worksheet 2. And then we'll do the last 3 examples and we can start the textbook work. So, domain and range. Let's start with this one and let's start with the domain. The question is, what is the point furthest to the left? Okay, that's the question. What's the point furthest to the left? The x value is -2 and it is included. We're including that point. Alright, then the next question. What's the point furthest to the right? Well, this arrow tells you it goes forever. It's going to infinity. That's what that arrow means. It means it's going in that direction forever. And so what we're going to do is we can write less than or equal to. Although infinity is not a number, it's a concept, right? It's going that way forever. Okay.
You can't include it.
Sorry?
So you can't include infinity.
Yeah, we're going to make that statement. Now, I might address the question you have. We'll just finish teaching first and then I'll answer. Any time we have infinity, so we're always going to make a statement like this, right? Left to right. Then what we're going to do is drop off the infinity. So our statement just becomes this one. And then, okay, the third step is for us to write it correct so that it's technically correct, the variable needs to be written first. Here we've got the number written first. And so what that means is we need to take this and rotate it 180 degrees like that. We're going to take it and rotate it 180 degrees. Now, if we do that, Noah, if we rotate it 180 degrees, what's happening to this arrow? At the moment it's pointing to the left, but if we rotate it 180, it's going to be pointing to the right. So we have to swap the inequality. Alright? So let's break down what we did there. We did what's furthest left, what's furthest right. We had infinity. We drop off the infinity. And then we need to make sure the variable is written on the left-hand side. So x or y, that's always the statement we have first. If you write something like this, you've got the correct mathematics, but the notation is not correct. So you won't get full marks if you make a statement like that. Okay? So let's continue on with that. So that's the domain. This is where we said x is greater than or equal to -2. And we can see that x exists for all values larger than -2. That's what that statement means. Values larger than -2. Let's look at the range for it. So, what's the lowest possible value of y? Well, this arrow says it's going down forever. It's going down forever. So the lowest value of y is not infinity, negative infinity. It's going negative forever. It's just going to keep going down. All right, less than y, less than. And what's the highest value of y? The highest point on the curve is +4, and it is included. All right. So always from left to right, from bottom to top. We've made the statement, and the next step, drop off the infinity. So if we get rid of the infinity, we've got the statement y is less than 4. Do we need to flip it? No. The variable's on the left. There's no flipping required. All right. So we've got the statement for this function. X exists for values greater than -2. Y exists for values less than 4. Y exists in that region. Very good. Let's move on to the next one. The point furthest to the left for domain, again, -4. It's included. And the point furthest to the right, this arrow means going up and across forever. So that's going to infinity. We drop off the infinity. And again, the x is on the wrong side. So we need to flip it, we need to rotate it around. And so we'll get x is greater than -4. Alright, so you're always drawing your arrows pointing to the left, and it's only if you have to flip them that you'll end up with them pointing to the right. Okay? So that's a domain. Now, how about the range? If we're thinking of the possible values of y for this one, let's draw a box so we're not getting confused. That's the first one. Here's the second one. That's our domain. That's the statement for our domain. For the range, possible values of y, we want the lowest value of y. And so we're not going to use this point because that's not the lowest point on the curve. The lowest point, the lowest possible value, here, -5. That's as low as it goes. And it's included, so we're going to have -5, less than or equal to y. And then what's the highest point? Well, there is a temptation to say here, that's as high as it goes. But this arrow tells you up and onwards forever. It's going that way forever. So we can put less than infinity. Whenever we write infinity, we drop it off. And flip it, because the variable is not on the left, we need to spin it around. Y is greater than -5. Okay, so then you can see the link here, right? Here's the statement. Y is greater than or equal to -5. Look at this function. All values of y on this line are larger than -5, or equal to, larger than or equal to -5. All values of x on this line are larger than or equal to -4. That's what that means. Now, when you get good at these, you'll be able to look at that and go straight to that statement. Okay, when you get good, you can go from there to there. But what I want you to get in the practice of is always pointing your arrows to the left, dropping the infinity, flipping them if you need to. Where people make mistakes is they point their arrows the wrong way. That's where they're losing marks. This is the foolproof method to guarantee. All we're looking for is that answer, but this is the foolproof method to guarantee that you're going to get the arrows pointing the right way with the right numbers. Okay, last one. Point furthest to the left, okay, is this one here. X is -3. It's included. Goes to infinity. Drop infinity. All right, the X is on the wrong side. Remember, the X needs to be on the left, so we need to flip it. So we flip the direction of the arrow. X has to be larger than -3. Okay, again, read that statement, understand it, comprehend it. Does X exist for all values larger than -3? Well, here's the point furthest to the left. X exists there and there. It doesn't exist any further to the left than -3. You got a problem, Kevin?
Question C, is it minus infinity or
That's infinity.
minus infinity because it's going?
It's the x-axis that's going opposite arrows. Instead of going the B minus, the arrow can go that way, basically.
Very good, yeah. So for when we're talking about X, we go furthest to the left, -3. Furthest to the right, if we keep moving to the right, that's positive infinity. Okay, so that's our domain statement. Let's do the range. Lowest possible value of y, it's going down. That's going to be negative infinity. I'll do it up here. Negative infinity going down. All right. Less than y. And the highest possible value of y, it's not here, that's only 4. It's here, 6. And it's included. We drop the infinity. All right. Let's read and comprehend that statement. The claim is all values of y are less than or equal to 6. Is that true? All values of y traced along here are going to be 6 or less. That is a true statement. Okay, so we've answered it correctly. So, look, I want you to start it like this, but when you feel confident, you make the decision. When you feel confident, you can go straight from looking at it to making a statement about the domain and range. Okay, so that's part 2. That's enough to do worksheet 2. Alright, so finish off worksheet 1, move on to worksheet 2. This one will take probably a little bit longer, and then we've got 3 more examples in a set.